Hi, Year 11. Okay, we're doing our radioactive decay multiple choice questions. As ever, have a look through the video, compare it to your answers, and if you're still not clear, come and find me and ask me. Okay, it's your job to let me know if there's anything you still don't understand. Let's look at question 1. We've got something decaying by emission of a beta particle, and we know that a beta particle is just an electron. Okay, and we're asking about which row is correct. We're being asked what decays and what happens to the atom. A good way of doing this is to kind of do process of elimination, and we'll start with this column here on the left-hand side, which is to say what decays. Now, you should be aware that when we're dealing with any type of radioactive decay, we are dealing with decay of the nucleus. Okay. Often students get this a bit confusing because beta particles, as we just said, are electrons. Electrons normally exist on the outside of the nucleus. However, this electron is particularly produced inside the nucleus. So actually, we're looking for either A or B. C and D are out. We do not have the outer layers decaying. Then we've got to think about what happens here. We've either got, it becomes a different or it becomes a lighter version. Let's have a look. Okay, let's try and write up our beta decay. If we have the element X with our nucleon numbers A and Z, and it does beta decay, in this case beta minus, well, that produces a new element Y, okay, and our beta particle. Now you should be aware that our beta particle, the way we write it, is a 0 and minus 1. Okay. Now, in order to do this equation, we need to balance the numbers. A on the left-hand side has to equal everything on the right-hand side. We've got 0 here, so this number must be A. So we have the same nucleon number. What must change, however, is this Z. Because on the right-hand side we've got Z, we've got minus 1, so this has to be Z plus 1. Okay? Now what this means is that we've got the same A, i.e. the same number of nucleons, but a different proton number. And what this means is it has become a different element. Remember, every element has a different proton number. Hydrogen, proton number 1, helium, proton number 2, etc., etc. And so therefore we changed identity. So our answer here is A. Question number 2 is all about alpha decay. Okay? And this one I'd suggest that all we have to do is do a bit of a decay equation. This time we know our starting nuclide. We know that it is radon 219. And what it's doing is alpha decay. Okay, and we know that an alpha particle is a helium nucleus, and we often write it as 4,2 He. Sometimes you see it written as 4,2 alpha, both are okay. And then we've got whatever's left over. We have to balance the numbers, okay? 86 on the right-hand side has to balance. So we've got 2 already here. 86 take away 2 is going to give me 84. And I'm just looking at the answers here. I'm already seeing an indicator here that the answer is A, but we'll just finish it off as well. 215 take away 4, 219, sorry, take away 4 is 215. Excellent, and I know that's PO just from the answer, and so therefore it's also A. Okay, next one. Last one of our decay equations for this quiz. Okay, we've got radioactive nuclei decaying to give new nuclei, which are also radioactive. And we have a series of decays. This is what actually happens in radioactive decay. We have decay, for example, uranium becoming thorium, becoming something I don't know, becoming uranium again, becoming thorium and radium again. So we've got a series of decays. Okay, we're asked how many decays involve the emission of a beta particle. So not alpha, beta. All right, let's have a look. Remember, in beta decay, and we'll just bring it right back to the front here, we're looking for an increase in the proton number. Okay? In alpha decay, as we saw in the previous example, the proton number goes down by 2. So, this decay here, for example, uranium to thorium must be alpha because we've gone down by 2. However, thorium to the one that I don't know the identity of, has gone up by 1, and so therefore this must be beta. So we've already got 1 beta. This one to uranium again we're going up by 1, again this must be beta. And then we're going down by 2 and down by 2 again, and so I think we've got alpha and alpha there, and so therefore our answer here must be B, 2. Because we've got 2 beta decays to increase the the proton number. Last couple of questions are just about the nature of our decays, because we do have to keep this kind of in our minds, all right? Which statement about alpha and gamma is correct? Okay. Alpha particles are a form of electromagnetic radiation. Not true. Gamma rays are electromagnetic radiation. Alpha particles penetrate materials more easily. Also not true, because we've seen that paper stops alpha, gamma passes right through. So we can get rid of A and B. The emission of an alpha particle produces the nucleus of a different element. Ah, very good. This is our answer here. Okay, and we'll talk about that in a second. We'll just go to check D. Gamma rays are more ionizing. Well, again, we've talked in lessons that more ionizing means worse at penetrating. And so therefore, actually, this is incorrect. Alpha is more ionizing. Let's look at this one again. Alpha particle. Again, we've talked about that general form. And I'll just flip back to our question 2. Always good to refer back. Here, our radon became polonium. Okay, and that was due to the emission of our alpha particle over here. All right. We've got our alpha particle changing the identity of the unstable nucleus. So anytime you have alpha or beta decay, we're changing the identity. So just to flip back, our answer here is C. All right, last one. Which type of radiation has the greatest ionizing effect? Well, they all ionize. They all create positive ions. Okay, and we've talked in lessons about the ionizing radiation hitting the particles and knocking out electrons and causing ions to be formed. Well, remember with our ionizer, okay, the better at good ionizers, if there's such a word, mean bad penetrators. And don't worry, you'll see this in a second once my hand's off the... Okay, good ionizers means bad penetrators. Okay, so if you're wanting to think about which one has the greatest ionizing effect, you think about the one with the worst penetrating effect. Well, alpha is very much our worst penetrator, and so this means it is our greatest ionizer. And the reason for this is a big mass and a big charge. It means it's involved in lots of interactions. Okay, so we've gone through those answers. As ever, you can take your time to have a little look at those. You can have a think about your answers, compare them to mine, and obviously be ready to come and ask me your questions. Hope you enjoyed this, and let me know if there's anything I can answer you. All the best, folks.